Question number 4 in the EOT. Use the squeeze theorem to find limits. Now, what is this squeeze theorem? Let's go ahead and explain the squeeze theorem. Let's say, in general, like a general example, I have 3 friends. The first friend, I will call her Sarah. The second friend, I will call her Lena. Now I tell you that there is a third friend who is called Reem. Now Reem, she likes to walk between Sarah and Lena. No matter what happens, she likes to be between them. So she is in the middle. Now if I were to tell you that we know for a fact that Sarah, she walked and she went to the library. And we know for a fact, Lena, also she walked to the library. Now, if I ask you, where did Reem go? You will tell me, Reem is always walking between Sarah and Lena. So since she is always between them, and Sarah went to the library, Lena went to the library, then for sure Reem will also go to the library. And this is the idea of the squeeze theorem. So, the squeeze theorem says if I have a function called f of x, I know for a fact that f of x is always between two other functions called g and h. It is always between them, no matter what. Then I tell you that the limit of g as x goes to a is equal to c. So when x goes to a, g goes to c. Also, limit of h of x as x goes to a is also c. So if this one is going to c, this one is going to c, then f, which is the function between them, is for sure going to go to c. And this is the squeeze theorem. It's like you are squeezing a function between two other functions such that if I know where this one went, I know where this one went, then I can conclude where did this one go. So let's look at examples and how to solve using squeeze theorem. Now they want us to use the squeeze theorem to prove that identity. Let's read the question from the beginning. Use numerical and graphical evidence to conjecture the value of limit x squared sine 1 over x. Use the squeeze theorem to prove that you are correct. Identify the functions f and h. Show graphically that this function is between a function f and a function h. And justify that the limit of f of x as x approaches 0 will equal the limit of h of x as x approaches 0. Okay, now very simply, all we need to do here is that we are going to need to find this limit over here. We need to find limit of x squared sine 1 over x as x approaches 0. Now they are saying it's going to be bounded between two functions called h and f. We need to find them. Okay, step number 1 in solving when you are doing your squeeze theorem is that you are going to ask yourself, do I know something about these functions that is bounded? Well, yes, I know about the sine. Sine anything, no matter what theta is going to be oscillating such that it reaches a maximum point of 1 and a minimum point of -1. Same thing with the cosine. So your starting point is that you are going to say sine of 1 over x is for sure between -1 and 1. Now my goal is to make this middle part same as my question. My question says x squared sine 1 over x. So here I need an x squared. So what I do is I go and I multiply all sides of this inequality with x squared. So now I end up with x squared sine 1 over x is between minus x squared and x squared. Minus 1 times x squared is minus x squared. Okay, now my goal is to find the limit as x approaches 0. Since I know this function is always between these two, then if I know where this one is going, I can conclude where this will go. So now I will go and I will say limit of this as x approaches 0, limit of this as x approaches 0. Now notice the limit of x squared as x approaches 0 is 0. Limit of minus x squared as x approaches 0 is always 0. So with direct substitution. So if I know this goes to 0, I know this goes to 0, I know this is always between them, then where is this one going? It is also going to 0. So I will also say that the limit as x approaches 0 to this is equal to 0. So I will say by the squeeze theorem, limit of x squared sine 1 over x as x approaches 0 is equal to 0. Now, what are the two functions that this was bounded by that are called in the question f and h? Well, very simply, this is your f minus x squared, and this is your h, x squared. Okay, now we go to question 30. Why can't you use the squeeze theorem as you did in 29 to prove the limit of x squared secant 1 over x as x approaches 0 is 0? Okay, now we always start with the trigonometric function. We ask ourselves, do we know where is it bounded between what and what? Well, if you know that the graph of the secant, let's look at the graph of the secant here. So look at the graph of the secant. Notice that the secant keeps going up forever and it keeps going down forever. So the secant is not a bounded function like the sine and the cosine. And that is why we cannot use the squeeze theorem in this one. So only sine and cosine can be used with the squeeze theorem. What about the tan, cotan, all of these? Also no. Why? Again, if I go back here, look at the function cosecant. Cosecant is also not bounded. It keeps going up, it keeps going down. It's not oscillating between a maximum and a minimum. Same with the cotan. Look at the cotan. Keeps going up, down. Same thing with the tan. Keeps going up, down. But if you notice, if I were to plot the sine, so sine x, look at the sine. The sine goes up to 1, then back to minus 1, then up to 1, then back to minus 1. So it is bounded between 1 and minus 1. So now I will go back and I will say, because the secant function is not bounded like the sine function. So in the final, if they were to ask me about secant, cosecant, cotan, tan, your answer is going to be the same. Okay, now we go to question 31. Use the squeeze theorem to prove that the limit of root x cosine squared 1 over x as x approaches 0 from the right is 0. And again, they want us to identify the function f and h where this is bounded by. Again, you start with your trigonometric function. What do I know about the cosine? Just the cosine, no matter what is the angle inside. I know the cosine is bounded between minus 1 and 1. Then my next step is I need to make this middle part same like my question. My question has root x cosine squared 1 over x. So I start by saying that there is a square here. So if I square this, what do I need to do to this and this? I also need to square them. Whatever I do in one part, I need to do in the other parts. Then I see that there's a root x. So this means I need a root x here. So if I multiply by root x here, I multiply by root x here, I multiply by root x here. So now root x cosine squared 1 over x is bounded between 1 squared is 1. 1 times root x is root x. Minus 1 squared will be 1. Times root x is root x. So now, very simply, if I need to find the limit as x approaches 0 from the right of this, I need to find for the other two. If I know where the other two are going, I can know where this one, which is always between them, will go. Okay, limit of 0 from the right for root x will be 0. Root 0 is 0. This one will be 0. So if this is going to 0, this is going to 0, this one is always going to be between them. So where is it going? It will go also to 0. So I will write, by the squeeze theorem, the limit of root x cosine squared 1 over x as x approaches 0 from the right is also 0. And what were the functions h and f? Well, very simply, they were root x, root x. Now we go to the last one, which is question number 32. Suppose f is bounded. That is, there exists a constant m such that absolute of f is less than or equal to m for all x. Use the squeeze theorem to prove limit of x squared f of x as x approaches 0 is 0. Okay, so we start by absolute f of x less than or equal to m. Absolute value can be removed and m can be once positive, once negative. Because what do we know about the absolute? The absolute gets rid of the negative, right? So if I want to remove the absolute, I need to put back the negative. So I know f of x without the absolute will be between m and negative m. Now again, I do the same thing that I did. I want this middle part to be same like my question. I see that fx has x squared next to it. So this means, what do I need to do? I need to multiply all parts by x squared. Now I can find the limit of this, the limit of this. If they give me the same answer, I can know where this one in between is going. So I will say limit as x approaches 0 of this, limit as x approaches 0 of this. Now m is a number, so 0 square is 0 times any number is 0. Same thing here, this is 0. So since this goes to 0, this goes to 0, then I will know for sure that since this is always between them, I will say by the squeeze theorem, the limit of x squared f of x as x approaches 0 is 0. What are the two functions that it was bounded by? They can ask you this in the multiple choice. So you know that it is bounded by minus mx squared, mx squared. And that's it for the squeeze theorem. Now, if you are wondering, what if this answer came out to be different than this? So let's say, for example, this came out to be 5. Let's say this came out to be 0. Can I conclude where this one is going? No. This and this has to be the same such that this is equal to them. Okay? Now, if you want to understand it in the example that we did over here, Let's say I tell you Lena goes, for example, to the canteen. Sarah, for example, goes to the library, or let's say she goes to the gym. So this one went to a different place, this one went to a different place. Can I conclude where Reem is going? No, I have no idea where she will also go. Same with the functions. So the functions have to go to the same place such that you know this will go to the same place as well. And that's it for the squeeze theorem.